Hello, and welcome to Chemistry with Mr. Olson. Today, we're doing Phase Change Worksheet Question 24. An 18-gram piece of ice at minus 23 degrees C, that's 1 solid mole of water, 18 grams, is heated to make 155 degrees C steam. How many calories were required? And if we look at this diagram I have in the lower right of the screen, we see this is a 5-point question. We start off with ice at minus 23. We warm the ice, and then we melt the ice, and then we warm the liquid water from 0 degrees C to 100 degrees C, and then we boil the liquid water, and then finally we heat the steam. So there's 5 separate calculations we're going to add up. And we'll draw that over here on the left. Let's do it. Okay, so we start with ice warms. Ice warms. And our equation for ice warming, well, Q equals mc delta T equals, what is the Q? Well, let's look up the specific heat of ice. That's actually at the top of our worksheet. The specific heat of ice is 0.5 calories per gram degrees C. And of course the mass, we know the mass, that is, I'm just going to write 18 grams times the specific heat, 0.5 calories per gram degrees C times delta T. Our delta T is, we end up at 0 minus 23, so 0 minus negative 23 degrees C, and that will give us the calories required to melt the ice. Let's show our cancellations. Grams over grams, degrees C over degrees C, and it comes out to 207 calories. 207 calories to warm the ice. Okay. Now, next step is we're going to melt the ice. Ice melts. And so that our equation is Q equals M delta H of fusion equals, let's substitute. The mass, of course, 18 grams. 18 grams. Delta H of fusion of water is 80 calories per gram, which is on our reference sheet. And let's show our cancellation. Grams cancels grams equals, and we get, multiply that out, 1440 calories. Okay, so come on over and watch what I'm doing. Next, the next segment, that's where liquid water warms. And for that, we use our standard Q equals mc delta T. The mass, 18 grams. The specific heat of water, 1 calorie per gram degrees C. The delta T, well, this time we take the T final, which is 100 minus the T initial 0, that many degrees C. And let's show our cancellations. Degrees C over degrees C, and we cancel grams over grams. We do the math, and we get 1,800 calories. All right, the next segment is where we're boiling the water. So the water boils, and that equation is Q equals M delta H of vaporization. Once again, the mass is 18 grams. The heat of vaporization of water is 540 calories per gram. So, times 540 calories per gram. Show our cancellation, grams over grams, and we do the math, and that comes out to 9720 calories. And now, at last, we have to warm the steam. So we'll say steam warms. And our equation for that is, of course, Q equals mc delta T. The mass is 18 grams. The specific heat of steam from our worksheet up above is 0.4 calories per gram degrees C. So let's write that in. 0.4 calories per gram degrees C. And the delta T, let's see, our T final is 155 degrees. So on top, 155 degrees C minus 100 degrees C. And we show our cancellations. Let's see, degrees C over degrees C. And grams cancels grams. We're left with calories. That's good. And that comes to 396 calories. 396 calories. If we then take these 5 values and we add them up, we get the total, which is our answer, 13,563 calories, and that is how much energy it took to warm the ice all the way up to the steam. And hope that's helpful. So remember, you divide the question up into as many segments as you need to, depending upon whether we're dealing with phase changes or not. And if there is a phase change, we use one of the phase change equations, which does not have a delta T value, that happens at a constant temperature. And for those parts where there is a delta T, we use Q equals mc delta T. That would correspond to anywhere where we have a slope. There's a slope in the graph, then we have Q equals mc delta T. For the phase changes, for melting, it's Q equals m delta H of fusion, and for vaporization, it's Q equals m delta H of vaporization. Hope this is helpful. Have a beautiful evening. Ta-ta.